In July 2020, inside a Milwaukee boardroom, the sound of the American suburb officially broke. Briggs Stratton, the company that had powered nearly every lawnmower, snowblower, and generator in the country, filed for Chapter 11 bankruptcy. The numbers were a staggering collapse of mechanical trust. A brand that had built over 100 million engines and defined American yard work was suddenly carrying nearly $1 billion in debt, quietly reorganized and sold off to a private equity firm. The fallout was not just financial, it was physical. Small engine repair shops lost their most reliable anchor. Hardware stores shifted their shelf space. Homeowners, accustomed to replacing spark plugs and cleaning carburetors, were pushed toward a new era of unrepairable, sealed battery tools. The paradox is that Briggs Stratton did not collapse because their engines failed. They fell because the economics and the expectations of the American suburb no longer rewarded that kind of mechanical durability. But the real story of Briggs Stratton is not only the story of a 2020 financial collapse. It is the story of how a small gasoline engine shaped the American landscape and what happened when a country decided it no longer wanted to pull a cord on a Saturday morning. Every week, we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in Milwaukee in 1908. The story begins in Milwaukee, Wisconsin in 1908. At the time, the internal combustion engine, a machine that burns fuel inside its cylinders to create power, was still largely a heavy stationary piece of industrial equipment. If a factory, a mill, or a large farm needed mechanical power, that power was bolted to a concrete floor. It was forged in massive foundries, required a dedicated operator, and was completely immovable. Power belonged to heavy industry. It did not belong to the individual homeowner. Stephen F. Briggs, an electrical engineer, and Harold M. Stratton, a successful grain merchant, did not start their partnership with the intention of cutting grass. Their first joint venture was an attempt to build a 6-cylinder, 2-cycle automobile engine. The automotive industry in the early 20th century was volatile, and their car engine project quickly failed. But rather than dissolve the partnership, Briggs & Stratton pivoted to what the emerging automotive market desperately needed: reliable electrical components. They began manufacturing igniters, switches, and other small parts for early automobiles. Milwaukee at this time was a dense hub of foundries, machine shops, and skilled labor. It was a city that understood how to cast iron and machine metal at scale. Briggs & Stratton thrived as a supplier, but they were still only making pieces of a system, not the system itself. The breakthrough that would eventually put their name in nearly every American garage did not happen until 1919, when the company acquired the patent for the motor wheel from the A.O. Smith Company. The motor wheel was a peculiar invention, a fully self-contained motorized wheel, complete with a small single-cylinder engine, a carburetor, and a fuel tank, designed to be attached to the back of a bicycle to turn it into an early motorized scooter. The motor wheel achieved brief popularity. Surviving company materials indicate that it was even adapted to power a small vehicle called the Briggs & Stratton Flyer, effectively a wooden buckboard with a motorized fifth wheel pushing it from behind. The Flyer was incredibly cheap, but it was not the future of American transportation. However, the motor wheel taught Briggs & Stratton a crucial engineering and manufacturing lesson. It proved that a gasoline engine did not have to be a massive, stationary block of iron. It could be compact. It could be completely self-contained. It could be manufactured cheaply enough that a single consumer could afford it. By the early 1920s, the company realized the true value was not in the wheel, but in the engine powering it. They detached the small engine from the bicycle wheel and began selling it as a standalone power unit. This decision collided perfectly with a massive American void. Before the Rural Electrification Act of 1936, millions of American farms and rural homes operated entirely off the power grid. If a rural family wanted to operate a washing machine, pump well water, or run a small generator, an engine used to turn a dynamo and produce electricity, they could not simply plug it into a wall. They needed mechanical power. Briggs & Stratton introduced stationary cast iron engines like the Model Y and the Model FH. The Model FH, introduced in the mid-1920s, became a legendary piece of American farm equipment. It was an overhead valve single-cylinder engine that produced roughly half a horsepower. It featured a cast iron block. The main engine structure poured from heavy, durable iron, practically immune to warping, but extremely heavy to carry. On a Midwestern farm, this engine was a revelation. A farmer could bolt a Model FH to a wooden washing machine on the back porch, connect a leather drive belt, and replace hours of manual labor with the steady rhythm of a small gasoline engine. When the washing was done, the same engine could be unbolted, carried to the barn, and used to power a feed grinder or a water pump. These early cast iron engines established the physical DNA of the Briggs Stratton brand. They were simple, rugged, and designed to be repaired in the field. This era also built the foundation of a massive service network: the dealers, mechanics, parts suppliers, and manuals that keep a machine running after purchase. Hardware stores and farm implement dealers began stocking Briggs & Stratton spark plugs, gaskets, and carburetor parts. A farmer did not have to send the engine back to Milwaukee if it broke. He could fix it on a workbench with basic hand tools. By the 1930s, Briggs & Stratton had become the dominant supplier of small engines for agriculture and light industry. They refined their designs, moving toward the flathead configuration, an engine design where the valves sit in the block rather than in the cylinder head, keeping the engine simple, short, and cheap to manufacture. The flathead Briggs became the ubiquitous sound of rural American labor. But as the United States emerged from the Great Depression and World War II, the market began to shift. Rural electrification was rapidly making the gasoline-powered washing machine obsolete. The farm market was shrinking. Simultaneously, a new American landscape was being bulldozed into existence: the post-war suburb. Millions of Americans were moving into single-family homes with patches of grass that needed to be maintained. The early lawn mowers were heavy reel mowers, often requiring a strong operator just to push them, or powered by heavy cast-iron engines. A typical half-horsepower cast-iron engine of the era could weigh nearly 40 pounds. When mounted to a heavy steel mower deck, it created a machine that was exhausting to maneuver around suburban landscaping. The cast-iron blocks were reliable, heavy, and built for farms and factories. But America was about to change how it lived, and the new landscape would require an engine that a single homeowner could easily push across a lawn. The post-war American suburb was a completely new geography. By the early 1950s, millions of Americans had moved away from dense urban centers and into single-family homes in newly plotted subdivisions. This massive demographic shift created a new cultural expectation: the manicured lawn. Yard work was no longer an agricultural chore performed by farmers. It was a weekend obligation for the American homeowner. But maintaining a lawn required a machine. In the late 1940s and early 1950s, the most common lawn mowers were reel mowers, heavy cylindrical machines that required significant physical force to push. If they were motorized, they were usually powered by the heavy cast-iron engines that Briggs & Stratton and its competitors had developed for farm equipment. A cast-iron block, the main engine structure poured from heavy, durable iron, could easily weigh 40 pounds on its own. When bolted to a steel mower deck, it created a machine that was exhausting to maneuver around tight suburban landscaping, narrow walkways, and driveway edges. The market was waiting for a different kind of power. It needed an engine that was cheap enough for a single-income family to buy at a hardware store, and light enough that anyone in the household could push it across a yard on a hot Saturday morning. In 1953, Briggs & Stratton provided the solution that would define their empire. They introduced their first lightweight aluminum engine. The shift from iron to aluminum was a massive manufacturing risk. Aluminum is lighter than iron, but it is also softer. It melts at a lower temperature and is more prone to warping under extreme heat. In the early 1950s, using aluminum for a mass-market internal combustion engine, an engine that burns fuel inside its cylinders to create power, was an engineering challenge. The company had to figure out how to cast the metal without creating porous flaws, and how to line the cylinder bore with an iron sleeve so the moving piston would not immediately destroy the softer aluminum block. To achieve this at an industrial scale, Briggs & Stratton heavily invested in die casting, a manufacturing method where molten metal is forced under high pressure into a mold cavity, allowing for rapid, high-volume production of engine parts. Die casting meant the company no longer had to pour heavy iron into sand molds, wait for it to cool, and spend hours machining the heavy blocks. Instead, they could stamp out thousands of lightweight aluminum engine blocks in a fraction of the time. The physical difference was immediate and staggering. The new aluminum engine weighed roughly half as much as the cast iron models it replaced. A homeowner was no longer pushing a tractor engine. They were pushing a purpose-built suburban machine. This breakthrough in weight reduction collided perfectly with another mechanical revolution, the rotary lawnmower. Unlike the old heavy reel mowers, a rotary mower simply used a single blade spinning parallel to the ground inside a metal shroud. The rotary mower was far cheaper to build, but it required a lightweight vertical shaft engine to spin the blade directly. The 1953 Briggs Stratton aluminum engine was the exact power plant the rotary mower industry needed. Briggs Stratton also made a crucial design decision that separated them from some of their early suburban competitors. While other companies, like Lawn Boy, relied heavily on the two-stroke engine, an engine that completes a power cycle in two piston strokes, often making high power for its size but requiring the user to manually mix oil into the gasoline. Briggs & Stratton committed firmly to the four-stroke engine. A four-stroke engine, an engine that completes intake, compression, power, and exhaust strokes across four distinct piston movements, kept the engine oil separate from the fuel. For the average American homeowner, this was a massive advantage. They did not have to measure and mix messy oil into a gas can. They could simply drive to the local gas station, fill a red metal can with regular gasoline, pour it into the mower's tank, check the oil dipstick, and pull the cord. This engine was also entirely air-cooled, an engine that relies on fins cast into the cylinder head and block, using airflow from a spinning flywheel fan to shed heat. There was no radiator, no water pump, and no coolant to leak. It was a self-contained air-breathing four-stroke power plant that weighed less than 20 pounds. The aluminum engine fundamentally changed American retail and service networks. Companies like Toro and Snapper began ordering Briggs & Stratton engines by the millions, bolting them to their own brightly painted mower decks. Sears, Roebuck & Coors featured Briggs-powered mowers in their massive catalogs, shipping them to suburban driveways across the country. The American garage was transformed. It became a space not just for parking a car, but for storing the mechanical tools of home ownership. The smell of spilled gasoline, the stiff resistance of a pull cord, the sputtering start, and the steady governed rhythm of a flathead. Briggs & Stratton became the definitive soundtrack of the American weekend. It also expanded a vast repair culture. Because the aluminum engines were mass-produced and highly standardized, parts became incredibly cheap and widely available. A homeowner whose mower would not start could walk into almost any local hardware store in America, walk up to the parts counter, and buy a replacement carburetor diaphragm, a new spark plug, or a fresh air filter. Small engine repair shops multiplied across the Midwest and beyond, their walls lined with oil-stained service manuals and bins of identical replacement parts. Briggs & Stratton had successfully transitioned from building heavy industrial equipment to manufacturing consumer appliances. They had taken the internal combustion engine out of the factory and put it onto the front lawn. The aluminum engine was not just a piece of engineering. It was the key that unlocked the American yard, turning a heavy agricultural chore into a weekend ritual. By the 1960s and 1970s, Briggs & Stratton was no longer just a manufacturing company in Milwaukee. It was the undisputed architect of the American weekend. The aluminum engine had not only won the market, it had completely saturated it. During its peak decades, Briggs & Stratton was producing millions of engines every single year. At times, the company commanded more than half of the entire global market for small internal combustion engines. And in the United States, that dominance was nearly absolute. If an American homeowner bought a motorized piece of yard equipment between 1960 and 1990, the statistical probability was overwhelming that it had a Briggs & Stratton engine bolted to the deck. They powered the iconic red Toro mowers pushing through suburban grass. They powered the Snapper riding mowers with the rear-mounted engines. They powered the Craftsman lines sold through the Sears, Roebuck & Coors catalog, delivered to driveways from Ohio to California. They were the heartbeat of Aryan snowblowers, clearing Midwestern driveways before the morning commute. They ran the generator engines behind rural hospitals, the water pumps on agricultural irrigation lines, and the air compressors in small-town machine shops. To achieve this volume, the company had transformed its manufacturing footprint. The Briggs and Stratton facilities in Milwaukee, particularly the massive Burley Street plant, became a fortress of American industrial labor. It was a sprawling complex of aluminum die-casting machines, machining lines, and assembly floors, where thousands of workers turned raw metal into finished power plants. The scale of the operation was staggering. On the assembly line, a bare aluminum block would have its iron cylinder sleeve pressed in, the crankshaft dropped into place, the piston connected, the valves lapped, and the stamped metal shroud bolted on in a matter of minutes. This was not delicate, low-volume craftsmanship. It was brute force, high-efficiency American manufacturing. The engines were shipped out by the railcar load to equipment builders across the continent. The sheer scale of this industrial empire turned a specific mechanical sound into an American cultural identity. The flathead Briggs and Stratton engine, an L-head design where the valves were positioned next to the piston in the block rather than above it in the cylinder head, trading high performance for relentless simplicity, had a distinct governed rhythm. It was a mechanical sputtering, a hunting and surging controlled by a simple air vane governor that held the engine at a steady 3,600 revolutions per minute. That sound became the backdrop of American suburban life. On a Saturday morning in July, a person could stand on a sidewalk in a subdivision in Illinois, Texas, or New Jersey and hear that identical mechanical signature echoing across 5 different lawns. In an America where an engine could decide whether a yard was cut, a driveway was cleared of snow, a basement was pumped dry after a storm, or a child's go-kart moved down a dirt road. Power was not an abstraction. It was aluminum, fuel, heat, sound, repair, and trust. The genius of Briggs and Stratton during this era of glory was not just in making a reliable engine. It was in making an engine so universal that the brand name superseded the equipment it was bolted to. An American homeowner rarely said they needed to fix their lawnmower. They said they needed to fix the Briggs. This was the golden age of the flathead, and it birthed an entire secondary economy of American childhood. Because these engines were cheap, simple, and everywhere, they became the default power plant for the booming backyard go-kart and mini-bike craze of the 1970s. A 5-horsepower Briggs block, salvaged from a rusted rototiller, could be bolted to a welded steel frame. It was an engine that could be taken apart with a basic socket set on a driveway, understood visually, and put back together before dinner. It accidentally taught a generation of Americans how internal combustion actually worked. But producing millions of engines was only half of the equation. To maintain absolute control over the American yard, the company had to ensure those engines never stayed broken for long. They had built the machine. Now they had to build the largest mechanical support network the country had ever seen. To support the millions of aluminum engines leaving Milwaukee every year, Briggs and Stratton had to create something just as important as the factory: a shadow industry of service. The small engine repair shop became a permanent fixture of the American town. These were not glamorous dealerships. They were cinder block buildings, hardware store back rooms, and independent garages characterized by the smell of stale gasoline and degreaser. Inside, a mechanic stood behind a counter lined with thick, oil-stained parts catalogs. Pegboards were covered in replacement recoil springs, spark plugs, and air filters. The engineering philosophy of Briggs and Stratton during this era heavily prioritized this repairability. A perfect example was their ubiquitous Pulsajet carburetor, a device that mixes fuel and air before the mixture enters the engine, designed by Briggs to mount directly on top of the fuel tank. Inside this carburetor was a simple rubber diaphragm, a flexible membrane that used the engine's own vacuum pressure to pump fuel upward. When an American homeowner left a lawnmower in a damp shed all winter, the old gasoline would inevitably turn to varnish, and by spring the engine would refuse to start. The solution was not to throw the mower away. The solution was to walk into a local hardware store, buy a $3 replacement diaphragm, take a half-inch wrench to the driveway, and fix the machine in 10 minutes. This created a profound mechanical trust. The engines were not treated as disposable appliances. They were treated as capital equipment for the home. The ecosystem worked because the manufacturer, the local repair shop, and the consumer all operated on the same assumption. An engine was an investment worth maintaining. By the late 1980s and early 1990s, Briggs Stratton was a global industrial juggernaut. They were producing more than 10 million engines in a single year, marching toward a historic milestone of over 100 million engines built. Their aluminum blocks were being shipped to hundreds of different equipment manufacturers. A single engine family could be adapted to run a rural water pump in Nebraska, a go-kart in California, an edger in Florida, and a snowblower, a machine that uses an auger and an impeller to clear winter driveways in upstate New York. Their absolute scale created a moat that competitors found nearly impossible to cross. A rival could try to build a cheaper engine, but they could not instantly replicate the network of 30,000 authorized service dealers. They could not put their replacement parts on the shelves of every Sears, True Value, and Ace Hardware store in the country. Briggs & Stratton had not just captured the market, they had become the physical infrastructure of the American yard. But this empire was built on a very specific economic balance. The entire system relied on the assumption that a lawnmower was expensive enough to justify a repair, that a repair shop could afford to keep its doors open, and that an American homeowner still wanted to spend their Saturday morning pulling a cord and checking the oil. The machine had taught America to trust a sound, a pull cord, and a local repair shop. It had not solved what would happen when that entire system became too expensive to keep. The first crack in the Briggs & Stratton empire did not come from a lithium-ion battery. It came from a price tag. In the late 1990s and early 2000s, the American hardware landscape underwent a massive structural consolidation. The local independent hardware store, the place with the oil-stained parts counter and the mechanic in the back room, was rapidly being replaced by massive big-box retailers. Giant warehouse stores like the Home Depot and Lowe's changed the math of the American yard. These retailers possessed immense purchasing power. They did not want to sell a premium machine that lasted 20 years. They wanted to sell millions of machines at a fiercely competitive price point. They demanded that equipment manufacturers provide cheaper lawnmowers. To get a rotary mower onto a big box shelf for under $150, every component had to be cheapened. This triggered the first great market pressure that eroded the company. Force 1, iron, aluminum, fuel, and manufacturing costs. Briggs & Stratton was forced into a race to the bottom. They had to redesign engines not to last longer, but to cost less to build. Plastic carburetors began replacing metal ones. Internal tolerances were adjusted for rapid assembly rather than generational longevity. The aluminum blocks were still strong, but the ancillary components bolted to them were built to a rigid budget. But the most devastating effect of the big box era was what it did to the service network. This was Force 2, dealers, fleets, farmers, pilots, and service networks. For decades, the Briggs & Stratton ecosystem had relied on the local repair shop. But suddenly, the fundamental math of repair inverted. If an American homeowner left old gasoline in their mower over the winter, the carburetor would foul. In 1985, they would take the mower to a local shop, pay a few dollars for parts, and keep the machine. By 2005, the math had changed. The homeowner would load the mower into the trunk, drive to the repair shop, and the mechanic would quote $75 for a carburetor rebuild and labor. But that same homeowner knew they could drive 3 miles down the road, walk into a brilliantly lit big box store, and buy a brand new mower for $129. The homeowner chose the new mower. The old machine, with a perfectly solid aluminum block, but a clogged plastic fuel system, was dragged to the curb on trash day. This was the birth of the replacement culture. The small engine repair shop, once a staple of the American town, began to starve. The mechanical trust that had defined the Briggs & Stratton brand was broken not by an engineering failure, but by retail economics. An engine is only as permanent as the market's willingness to fix it. While Briggs & Stratton was fighting to make engines cheaper to satisfy the warehouse stores, a new competitor attacked from the top. Honda had been quietly building a reputation in the American yard with a different kind of power plant. They introduced small overhead valve, or OHV, engines. An engine designed with valves in the cylinder head rather than the block, allowing for better airflow, improved fuel efficiency, and a smoother combustion cycle compared to the old flathead design. The Honda small engines were significantly more expensive, but they possessed a devastating advantage. They were incredibly quiet, they vibrated less, and they reliably started on the very first pull. In an increasingly dense suburban environment, noise became a liability. A Honda-powered mower sounded like a precision instrument. A flathead Briggs Stratton, with its distinct, sputtering mechanical governor, suddenly sounded like a loud, outdated agricultural tool. To compete, Briggs & Stratton had to invest heavily in their own OHV designs, eventually rolling out successful overhead valve families of their own. But the market had already bifurcated. The premium mowers favored by commercial landscapers often wore Honda red. The disposable entry-level mowers wore Briggs & Stratton black. The company was still selling millions of engines, and their massive V-twin engines, a two-cylinder engine arranged in a V-shape to produce higher horsepower for riding mowers, remained a dominant force in larger yard tractors. But the profit margins on the smaller walk-behind engines were razor-thin. They were trapped maintaining massive American factory infrastructure while competing against increasingly cheap offshore manufacturing. The engine was still the undisputed king of the American lawn, but the foundation beneath it was hollow. And while the industry fought over the price of a carburetor, a completely different kind of power was already charging on a workbench in the American garage. The final blow to the Briggs & Stratton residential empire was not dealt by another gasoline engine. It was dealt by Force 5, electrification, hybrids, batteries, and convenience displacement. For decades, electric lawnmowers had existed, but they were tethered to long, frustrating extension cords that snaked across the grass, or they relied on heavy lead-acid batteries that took a day to charge and barely lasted 20 minutes. The internal combustion engine remained safe because it was the only technology that offered true untethered power. But in the 2010s, the chemistry of the American garage changed. High-voltage lithium-ion batteries, power storage units that could hold a massive electrical charge without the heavy weight or rapid degradation of older battery designs, began to infiltrate the hardware store aisles. At first, this technology was restricted to cordless drills. Then it moved to string trimmers and leaf blowers. Eventually, the battery packs became large enough to power a rotary lawnmower. This new electric equipment completely bypassed the traditional mechanical service network. A battery-powered lawnmower has no carburetor to clog. It requires no oil changes. It has no spark plug to foul, no air filter to replace, and no recoil spring to break. To an aging generation of homeowners, or a new generation buying their first suburban houses, the appeal was undeniable. The American yard no longer required a trip to the gas station. It only required a wall outlet and a plastic charging dock. The cultural shift was absolute. The Saturday morning ritual, the smell of spilled fuel, the physical exertion of the pull cord, the mechanical tinkering, was replaced by the push of a plastic button. The neighborhood grew quieter. The replacement culture that big box stores had started was finalized by battery technology. When a lithium-ion mower eventually broke, or the battery refused to hold a charge, there was no independent shop to fix it. The homeowner simply threw it away and bought a new one. Briggs & Stratton was caught in a brutal industrial trap. They were a company composed of foundries, die-casting machines, and mechanical engineers. Their absolute mastery was in atomizing liquid fuel and turning it into mechanical torque. They were not a software or battery chemistry company. As the residential market eroded, Briggs & Stratton attempted to pivot. They expanded aggressively into commercial landscaping equipment, acquiring brands like Ferris, known for heavy-duty zero-turn mowers. They pushed into the lucrative market of home standby generators, large stationary engines permanently wired to a house that automatically start during a power outage. They built highly capable, commercial-grade V-twin engines that could run for thousands of hours. But the foundation of their empire, the tens of millions of cheap walk-behind mower engines that had funded their massive Milwaukee infrastructure for half a century, was crumbling. By the late 2010s, the financial mathematics of the company no longer worked. They were carrying the immense overhead of legacy American manufacturing facilities, funding a massive pension system for retired factory workers, and fighting a desperate price war against foreign engine builders on one front and battery tool manufacturers on the other. Then came the spring of 2020, The global supply chain seized up. Retail channels were disrupted. For a company already operating on the edge of a financial precipice, it was an impossible gap to bridge. The final reality was Force 6, corporate consolidation, acquisition, and brand survival. In July 2020, inside a boardroom far removed from the oily workbenches that had built its reputation, Briggs Stratton filed for Chapter 11 bankruptcy. The numbers were a devastating reflection of how drastically the American market had shifted. The company that had built over 100 million engines was carrying nearly $1 billion in debt. To survive, the company was sold to KPS Capital Partners, a private equity firm specializing in distressed manufacturing. Briggs Stratton did not disappear. The name survived. The production of commercial engines and generators continued under new ownership. But the era of the independent, ubiquitous small engine empire, the era where a single company in Milwaukee provided the absolute mechanical heartbeat of the American suburb, was over. The engine still ran. The orders slowed. The rulebook changed. The parts got harder to find. The factory line moved. The sound faded. The badge remained. The world it powered was gone. Briggs Stratton did not die. The badge survived the 2020 bankruptcy. Today, under the ownership of private equity, the company still operates. It still builds engines. But the strategy has shifted. The modern iteration of Briggs Stratton is heavily focused on commercial landscaping equipment, high-end Vanguard V twin engines for job sites, and the rapidly expanding market of home standby generators. They survive by moving upstream, abandoning the absolute dominance they once held over the entry-level American front lawn. The name remains, but the era of the company acting as the undisputed default mechanical heartbeat of the American suburb has quietly closed. Yet the physical legacy of their glory days is impossible to erase. If you walk through a rural swap meet in Ohio, attend an antique tractor and engine show in Pennsylvania, or browse the thousands of restoration channels on YouTube, you will find an endless sea of Briggs Stratton aluminum and iron. You will see rows of the old cast iron Model Ys and F8s sputtering away, belted to antique water pumps. You will find workbenches covered in the stamped metal shrouds of 1970s flatheads, their owners carefully cleaning the varnish out of Pulsajet carburetors. There is an entire American enthusiast community dedicated to keeping these specific engines alive. They trade oil-stained service manuals online. They hoard new old stock gasket kits. They dig through salvage yards to find original recoil spring assemblies. One of the most surprising footnotes in the history of this lawnmower engine company is its massive, enduring legacy in American motorsports. Long after a homeowner might have thrown away a rusted rototiller, the 5-horsepower Briggs Stratton flathead block found a second life on dirt tracks. For decades, it was the foundational power plant of American go-kart racing. A block designed to govern at a steady 3,600 revolutions per minute, while cutting fescue was modified, ported, and rebuilt by backyard mechanics to scream past 6,000 RPM. The famous Briggs Stratton Raptor racing engine became a legend in its own right, proving that the basic aluminum architecture engineered in Milwaukee was incredibly overbuilt. But the preservation of these engines is about more than just backyard racing or antique collecting. It must pass the test of why this history actually matters. This is not simply nostalgia for the smell of old exhaust or the noise of a Saturday morning. A preserved Briggs Stratton engine on a garage workbench is a physical argument about a vanished relationship between Americans and their machines. It is a working relic of a time when power was mechanical, visible, and democratic. When you look at a flathead gasoline engine, you can see exactly how it works. You can trace the path of the fuel from the tank, through the carburetor, into the cylinder. You can take a wrench, remove the cylinder head, and physically watch the piston rise and the valves open. Because it could be understood, it could be fixed. Because it could be fixed, it belonged entirely to the owner. The modern lithium-ion battery tool is a marvel of convenience. It is quiet, it does not smell, and it requires zero maintenance. But it is also a sealed, unrepairable black box. When a battery pack eventually fails, the homeowner cannot open it up, clean a contact, and make it work again. They are forced back to the big box store to buy a replacement. The shift from the small gasoline engine to the electric motor was not just a shift in fuel, It was a shift from a culture of ownership and repair to a culture of consumption and replacement. The old factories tell a similar story. The sprawling industrial complexes in Milwaukee, like the massive Burley Street plant that once employed thousands of workers pouring iron and die-casting aluminum, have seen their engine production lines go silent or be repurposed over the decades. The manufacturing footprint was forced to scatter, chasing cheaper labor across the American South and eventually overseas, leaving behind the heavy industrial memory of the Midwest. What vanished was not just a brand's market share. What vanished was a massive, interconnected American system. It was the local hardware store parts counter. It was the small engine repair shop with its pegboards of spark plugs. It was the mechanical initiation of a teenager taking apart a carburetor on a driveway. America did not stop needing its lawns mowed or its driveways cleared of snow. It simply stopped needing that work to be done by a machine that required a wrench, a gas can, and a Sunday afternoon to keep it alive. But the iron and the aluminum are stubborn. They do not disappear just because the retail math changes. They wait in the dark. Somewhere in an American garage, an old Briggs Stratton engine still sits under a faded mower deck, the pull cord stiff, the metal shroud scratched, waiting for a Saturday morning that no longer sounds the same. See you in the next one.